Here's the solution to question 2 of homework 11. From the question 2, we have to solve 3 problems and figure out these functions and figure out whether these functions may represent an autocorrelation function or a spectral density function. Let's begin the solution. First, setting v equals to eta and f, and from the title we know that f eta equals to either minus the absolute of eta, and this one and the Fourier transform of this equation equals to 2 over 1 plus w square, and this one is non-negative. And setting v equals to w, fw equals to e minus the absolute of w, and this one is also non-negative, so fv may represent both functions. Both functions means that autocorrelation function and spectral density function. Now let's begin the second problem. Is let's first setting v equals to eta and f eta equals to sine eta square over eta square, and this one and the Fourier transform of this one equals to this figure, and from this figure we know that this one is non-negative. And setting v equals to w, fw equals to sine w square over w square, and this one is also non-negative, so fv may represent both functions. And then the final problem is and let's first setting v equals to eta, f eta equals to 1 for the absolute of eta is smaller than or equal to alpha, or equals to 0 for the absolute of eta is larger than alpha, and the Fourier transform of this one equals to sine w over w, which is not non-negative, so fv may not represent an autocorrelation function. Then setting v equals to w and fw equals to sorry, I made a mistake, and this is 1, this is 0, so when w absolute of w is smaller than or equal to alpha, fw equals to 1, and when absolute of w is larger than alpha, and this one and fw equals to 0, so this one is non-negative, so fv may represent a spectral density function. That's all. Thank you.